I'm Joshua Bardwell. Welcome to Rotor Riot, and today we are talking about racing versus freestyle. Which is better? No. How do you set up a racing quad versus a freestyle quad? In order to help address that question, we have today Stinger Swarm, one of the top freestyle pilots in the world, if I do say so myself, and Captain Van over here, legit one of the top racing pilots in the world. I think that's fair to say. And we've got Zachary Thayer, Anoop, one of the top pilots in the world, probably most prominently known from DRL. And we have got a ton of their quads with us right here on the table. Let's start out by talking about the major differences between them. How about weight?
Wow.
How about weight?
So I've done very little racing, but when I did race, one of the things that I was looking for was getting the lightest setup I could possibly find to get the thrust to weight ratio as high as possible. Now with the freestyle frame, I've found over experimentation that I like my setups to be somewhere in the range of 600 to, I would say, 650 grams with everything all up in the air.
And you hear that a lot, that freestylers kind of like their frames heavier. Do you agree with that? When you fly freestyle, do you like a heavier quad?
Yes and no. I guess there's it depends on the type of freestyle you want to do. So I've noticed that the more you want to be precise and in proximity with things, the easier it becomes when your quad is a certain weight. Because if your throttle's too, ready to go and too excited, it's really hard to be very close and very accurate. So the weight helps dumb down a system, but you can still use that power to hit high speeds. You just don't accelerate as fast.
Now, one of the things that I like about a higher weight, what you're saying there is absolutely true. If you dumb down the thrust to weight ratio, then it gives you a little bit better throttle resolution so that you can be just a little bit more precise and get closer to things. But also that extra weight helps carry momentum when you're doing something like a longer inverted over something. If you have a very low weight and still have the same amount of drag, it slows down and it won't carry over objects the same. Whereas if you have that weight and you have the drag, it will carry through the drag.
Now, I've never heard a racing pilot say he ever wanted a heavier quad.
This is true.
And I've never heard a racing pilot say he wanted to blow out corners.
Yes.
What are racing pilots thinking about?
So when it comes to racing, the first thing I'm thinking about is how low can I get the weight, number one. I definitely don't want a heavy quad, because in my opinion, a heavier quad definitely carries more in the corners in a bad way. It also, just in my opinion, is not as nimble in the air. From a racing standpoint, we want to get the highest thrust to weight ratio. So we want to figure out how to put the biggest motor on the lightest frame, but yet still have enough durability to where if we crash, we're not going to break anything.
And the weight also affects your flight time, doesn't it?
Yeah, it does.
Lighter quads fly longer?
Yes and no. It's really, we went through this last year for multi-GP nationals and the regional finals. In theory, the lighter weight quads were more efficient. However, it really ended up being what motor you put on. So, for example, some motors would be really good on a 240 gram quad and really efficient. But if you increase the weight to 260 grams, that same motor had worse efficiency because the motor. I mean, it's one of those things. It really depends. Definitely lighter weight in general, though, has better efficiency.
Well, now, in theory, but if you are hovering, then yes, you'll get the longer flight times if you're just hovering. But when you're in fast forward flight, such as racing, the bigger use of that battery is going to be overcoming drag more so than holding it in the air. At that point, holding it in the air is like a small sliver of where that thrust is going to. Most of it's going to making turns and maintaining speed
and overcoming air resistance.
Exactly.
Overcoming air resistance. Yeah.
Well, and the lighter setup too is nice because when you're taking tight technical corners or whatnot, compared to a heavier race quad or even a freestyle quad, you actually save efficiency by taking corners tight with less throttle. So it's a trade-off. It definitely am hungry in the straightaways because it's light, you can go fast, but at the same time on a technical course or whatnot, you actually save battery life by.
Oh yeah, I would not recommend a heavier quad for racing. That's not what I'm saying at all.
Of course.
Who would ever recommend such a thing?
I would actually recommend it on certain courses. And I know it sounds completely asinine and crazy, but say you have a course that's like a jungle gym or you're flying through tunnels. It is insanely hard to fly a lightweight setup, especially with more and more camera tilt. So a good example would be FPV light tracks. Those tracks are near impossible to fly with a super powerful lightweight quad because you have a ceiling and walls the entire course. So to do so, it's much more challenging with your throttle resolution.
You know what? I might agree with you on that. I'd not thought about it, but when we went to the what was the race we did in Phoenix that I was there for? Do you remember?
Phoenix Cup.
Phoenix Cup.
Was it the Phoenix? Okay, that was a light tracks course, and I had a lighter weight racing quad, and I crashed out every time. I didn't qualify because I couldn't get 3 laps in consistently. And when I went to IO, I ran the Stingy frame on the light tracks course there, and my freestyle setup, and I just kept getting faster and faster, and for a small sliver of time, I had the fastest time on that track. Until I exploded and McGap came in and just destroyed me.
I don't agree, though, with what they're saying. I agree that in some instances, like on I've flown a lot of light tracks recently. I went to the XTC teaming race. I also went to the Phoenix Cup just a week before that, and that was my first ever experience with light tracks. I had Stingy frames. I had my normal Win 5 frames, and I actually found that while the heavier frames definitely, like, it really depended on the course. Like, the heavier frames, I guess it was maybe a little easier to fly, because first off, it slowed you down. But also, I mean, it kind of like that weight almost was like pulling you down, so like you had more reaction time. But at the end of the day, we're at like a skill level with racing pilots now, where if you're at a race like that, if you're not flying a lightweight, very powerful quad, it is harder to fly through, you know, small gates and with ceilings, but you're not really able to compete with the heavier quad because you're not going to be able to keep up with other people.
Well, it very much depends. So what I started out by saying is it's a track-dependent situation. So if you look at, say, XDC2, we were inside this tiny plaza with tiny gates and a tiny net. It was a singular, super vertical, super slow track. We're going fast because you just barely bumped your throttle. It was actually a massive negative. So we ended up seeing everyone like switching over to 4-inch and adding GoPros to their quad to fly this.
But you could just down
the consistent thing I'm hearing you guys say is that the heavier quads give you a sort of a damped throttle response that can be better for proximity freestyle for sure, and for maybe tight technical tracks where just even the top pilots would have a little bit of trouble with a super responsive quad.
I definitely agree. It depends on the track though. So the track example I'm giving is on almost any quad. If you blip the throttle too much, you will be flying across the entire course and into a net. Yeah. So we're talking about very confined type racing.
I don't know. The way I've combated that in the past with like XCC and Phoenix Cup is I've just taken my normal setup and I've just downpitched the prop. That's how I've solved that issue.
Speaking of weight, there's one big difference between freestyle and racing pilots, and that is freestyle pilots usually carry a GoPro, and racing pilots never do. So that certainly is going to make up a big difference in the weight.
Yes and no. So like, I think it definitely adds like the weight to like 800 grams, but at the same time, from what I see in freestyle frames versus like a racing frame, in a freestyle frame it's usually a bigger frame that supports the GoPro and a battery usually on top. So like in general, because it's going to be carrying a GoPro, it's going to be a bigger frame. Usually just by that for itself is going to be heavier. Like the dry weight of this compared to this is about 50, I think it's way more than that actually. This is almost like 100 grams heavier dry weight from this to this, and it's like almost the same setup as far as electronics.
Yeah. Now you talked a little bit about pitch. You said you talked about down pitching props. So let's talk about prop choice for racing versus freestyle. What are the differences between like what a freestyle and a racing pilot would pick? I know you do a lot of thinking about props.
Yeah.
You helped design worked on the racecraft props, the Avon Flow props that are on the Emax Hawk 5.
I helped with my cousin when we kick-started him going into prop design and prop business, and we started with the Racecraft 5051. And so there's like this crazy sort of ordeal going on with props, I would say. Props are coming out all the time, different pitches, different shapes, different designs. So particularly what we did is we wanted to take like a step back, and we wanted to go, well, what if we engineered a prop for a very specific goal? What happens there? So that was our take on it, and that's what sort of these props that we're coming out with end up being. And it ends up being a bit different than everything you see. So we really wanted linearity and throttle response. So what actually happens is these props sort of feel a little bit more dead. You have to move your throttle more, which is maybe a negative, maybe not. It depends. You do have to relearn them a little bit because they fly different. And then the other thing we do is we target a specific speed and power consumption, which, comes with what seems to be a downside, but maybe it's a positive side at the same time. But it very much highlights that motors lose out efficiency at high throttles, which I think a lot of us realize is as soon as you hit like 90% throttle and above, the acceleration sort of drops off and your power consumption goes up. So with our prop designs, we recognize this even more because our target is always around 60% throttle. So above that, it starts getting very, very heavy in the amp draw. But we've also noticed that the speeds go up a lot. So in the case of the 5051, people were sort of topping her out around 90 miles an hour at the time. This is, a year and a half, almost 2 years ago. And then we came out with this prop, and if you had enough battery and motor to drive it, people were easily exceeding 100 miles an hour.
Which prop then? You came
The
up with
Racecraft 5051.
Okay.
So we saw this sort of new paradigm shift where people now were like, oh, we can go to bigger motors, we can go to a bit pitchier props and all this stuff. And then everyone started jumping on board, and we're seeing a lot of prop choices now. So I would say prop choice can definitely heavily change how you're flying on a track.
What kind of props does a freestyle pilot, what is a freestyle pilot thinking about when he picks props, Stingy?
So for me, I make different prop choices depending on where I'm flying and what it is that I'm going for. I am not involved in prop design, so I just take what I've tested and what I know. Both of my quads are running the V1S props. This one is the 5.1 pitch prop. It's a much more aggressive prop. The other quad is running these, which is the 4.3, which is a fairly low pitched prop. If I'm doing something where I'm outdoors in a big space and I'm looking to hit higher speeds and a lot of punch outs, then I like the more aggressive prop. If it's more of a proximity thing and it's not so much about getting up to speed fast, it's about just having a nice flow or hitting precise gaps, I prefer a better throttle resolution that you get from a lower pitched prop.
When we say pitch, by the way, in case anybody's not really clear on what we're talking about, that's basically how steep the prop is pitched. And a steeper pitch prop is going to make more thrust, but it's also going to make the motor and the battery work harder. And some would say have less, you say throttle resolution, by which you mean how much you feel kind of a difference in thrust when you move the throttle stick.
Yeah.
A lower pitch prop is going to be more responsive because motor has to work less hard to spin it.
Yeah, and there are other factors that go into just how responsive a prop is. If you run a really high-pitched prop with a motor that has a small stator size, then it is going to take it a lot longer to spool up. Mm-hmm. If you run a large stator size, it's going to spool up any prop faster, whether it's low pitch, but it's going to draw a lot more amperage. So yes.
Now, Alex, I see a lot of racers who are running like 50-51, really high-pitched props.
Right.
Is that do you do that as well?
Yes and no. So it really kind of what Kevin touched on a little bit. It depends on the course, right? So I've had instances recently where, like, on tight courses, I actually prefer the higher pitch prop with the higher kV, bigger stator motor. I like the control. I like the quick bursts of top end power. But at the same time, we also are moving into courses now, no matter what the voltage is, where like you're trying to get efficiency, and so we're actually down pitching our props. So for us, really, it's almost kind of the opposite. If you're outdoors with a freestyle quad, for us, we have a really big long track. We're going to run a really light pitch prop because we're going to be at full throttle the entire time. Mm-hmm. And we want the efficiency. Whereas if we're on a more tight technical track, we don't worry as much about the efficiency. We want more control, which a lighter pitch prop doesn't really give us on a tight track.
By control, you mean like the ability to thrust and get around the corners.
Right, so how well it corners, does it wash out? The acceleration's a big thing for us. Those are just some of the things I mean by like control.
So that being said, I think there's a common misconception of sort of the overall like efficiencies that happen. So there's like, what if I told you right now that the Avon R, which is commonly known to be this insane monster prop, way too pitchy and all this, is actually the most efficient prop you can buy. There's this misconception where it's people look at what full amp draw is. You know, when you go full throttle, what does this motor do? But you know, full throttle, as we discussed earlier, is not the most efficient point on a motor. Mm-hmm. Motors really have this power distribution curve, and it's like a belt chart. So there's a point, and it's usually 60 to 70% throttle, where motors really shine in their efficiency. And so that's what we're doing with these props, is we target them for that. So if you were to take, you know, the Avon R, grams per watt at that throttle is hyper efficient. So what about, you know, tailoring your flying to match your setup for a race?
Okay, let me pause right there, because what you just said is very important. Grams per watt. Your watt has to do not only with your amp draw, but also the voltage that is going in. So that before we even get to talking about the props, we're talking about both which type of battery you're running and how many amps the motor is pulling for that battery. Then we have to factor in how many grams of thrust you're generating for that amount of wattage, right? So you can test these prop A and it's pulling 80 amps on your setup, mm-hmm. and now prop B is pulling 120 amps, but prop B is way more efficient because it's making that much more thrust. It's not if you switch and see an amperage change. You can't make the judgment based on that alone. There are a lot of factors that are going into whether or not a prop is efficient.
So that being said, back to this prop example, is this is the most efficient prop that you can buy on the market. But the problem lies is if you go above its threshold where it was designed, it starts consuming a lot of power and the efficiency drops off fast. Where's the middle ground? Would it be better to cap your throttle percentage on a very aggressive prop like this that we do know is hyper efficient because we have the math behind it? Or do you let your throttle just run wild and put a prop on that you can't pull that many amps with, but maybe you have less control? So I think there's still like a lot of room to grow in all of this and figure it out.
Let's talk about tuning differences. And I don't want to get too deep into the minutiae of tuning, but I've always said that freestyle pilots are pickier about their tune than racing pilots, because freestyle pilots want this ultra smooth, zero jello, no prop wash. And I've always said racing pilots are probably more willing to tolerate a little bit of oscillation. But I kind of wonder if that's true, and I want you guys to weigh in. Do you think that that's true? Let me ask the racing pilot. How much do you care about prop wash oscillation in the corners, etc.?
I care so much, especially like I guess at my level I'm flying at, because for me, I know like I can literally see differences in lap times based on prop wash and corners. As far as like the rest of the quad in the air, stick feel again is important. So like I tune PIDs based off of getting the quad to fly properly, and then also stick feel after that. So I actually disagree. I think tuning from like a racing standpoint is more important. I fly freestyle as well. I really don't care about my freestyle tune that much, but again, I favor racing, and so for me, I think a lot of racing pilots don't care too much about their tunes. They run stock at this point with like Beta Flight 1. It all flies so well, they don't care, but I think you'll see more of the top-end racers are spending a lot of time fine-tuning their stuff because they want it to fly 100%. They want all that performance they can get out of it.
Okay.
I'm a freestyler who would actually agree, because I can have a quad that isn't the best tune and fly around it and still make good footage, and it feels exactly how I want it to feel. He doesn't get the option of always avoiding his prop wash or always easing into the throttle. He needs to be able to jump right into that throttle, which I don't have to. As long as I'm planning ahead and know exactly what it is that I'm going to be doing, I can be a lot more subtle with the throttle changes. So I would tend to agree that racing the tune is a little bit more important.
I fully agree. So like my take on it is you make your freestyle quad fly the way you like it to fly, so it's easier to do what you want to do. Yep. But racing, I think there's a technical side that people ignore completely, and that was to your point of racers may not care as much. And I've actually, over years of testing, have found out that if your quad is over-tuned too tight with racing, you actually pull a lot of amps. You pull more power out of your quad. So when you go and you want to, like, say, a snappy traditional freestyle tune where it stops on a dime, you're actually running really high Ds, which makes your motors work a lot. You may not see it, you may not hear it, and it may fly nice, but you'll actually get less peak power and draw more amps. So there's this weird balance with race tuning where you need it to behave, you need it to not do silly things, but you also need it to be a little bit softer of a tune so that when you are flying, you're not wasting power to try to do extra stabilization that's not fully needed.
Okay, let's get back to the sort of mechanics of the quad itself, and let's talk frame geometry. So there's a couple prominent geometries. One is what you might call the pure X, which is the motors are in a symmetrical square. We got an example of a pure X here on the table? Pure
Lots
X.
of them.
Pure X. Another one that you see is the stretched X. Do we have any stretched X?
You're holding one.
This is a stretched X. The motor is longer front to back and narrower side to side. And another one is what I've heard called the H style, which is where the motors are wider versus longer. What are some reasons you might choose one of these geometries versus the other? Who flies?
Let's start with the H.
I have a bit of a talking point about this. So I started, I designed frames myself. I made the Shrike, and now I make the Brap and the Steez. And these have been pretty popular racing frames. At least the Shrike was like one of the first sort of lightweight, micro, tiny pod
Remember
things.
the Shrike?
So with that point in mind is the reason I went True X at the start. So this is with old firmwares and all this. Is it always behaved better. Our flight controllers were not that good, and we had a lot of issues with when you misbalanced and misaligned things. And at the same time, our powertrains were a lot more limited as the excess power we had. So when we shrank the footprint and we were able to make it a True X, it seemed to fly a lot better. That being said, when we fast forward to today, the choices are now more based off preference, and a little bit of sort of with GoPros and Freestyle, when you squash the X, you can remove props from view. So I think that is a bit more prominent, at least for me, for Freestyle, whereas the true symmetrical X
So here you're talking
has
about,
a very
you're talking about
Yeah.
the H-style frame.
Right.
Yes.
Where the props move back and out, and they get out of view with the GoPro.
Right,
Which
you get that, and then I talked with Steel a little bit, and you get a little bit different yaw behavior and a little bit more sensitivity on pitch because your weight bias versus your actual leverage bias shifts.
With the H-frame, it is absolutely easier to get the props out of view. And I don't want to make this about personal preference, but one of the things that happens when you have the H-frame, especially with a top mount battery, is you've now, the bulk of your weight is distributed in this manner. And so when you roll,
the prop line?
yeah, well,
I agree.
I'm not worried about above the prop line.
It's
just
the
yet.
leverage bias.
It's
We're
front to
talking
back,
about the
front to
leverage.
back.
It's having to, for roll, everything is now on that roll axis. But for pitch, now everything is spread out along the pitch axis
And then you
on the
smush
plane,
pitch.
and we've reduced the distance from the center of mass for these motors. So the motors are not as effective on the pitch axis, and the weight distribution means that you need more effectiveness on the pitch axis. So with a True-X, there's so many trade-offs. With a True-X and a top mount battery, now you've elongated it. Or you have a True-X with a bottom mount battery, and both roll and pitch, because everything is centered then around yaw, right? But with roll and pitch, now they both are fighting the same amount of weight distribution. You see what I'm saying?
Yeah, the one disadvantage to going GoPro on top and battery on bottom is you're now separating your mass volumes.
Yeah.
So that you get another additional behavior where now you're making both axes work harder.
Yeah.
So top mount sort of alleviates that, but I agree, where when you run a True-X, you get more leverage to move that weight down the center for Freestyle. But when you go with the Squash X, you get the props out of view, and generally you can sort of tune it out, but you do end up with like weird behaviors at full throttle where you need the rest of the power down.
Now,
Yeah.
nobody seems to be talking about stretched X, and I've heard a lot of people say that stretched X is more common for racers. Alex, I wonder if you'd like to weigh in.
I love stretch decks. So I've only actually been racing for like a year and a half. I've flown a lot longer than that. So I've flown everything still. I've flown True-X, I've flown Squish decks or whatever. The reason when I flew my first stretch decks on a course, I had it set up the exact same as a True-X frame. It was a X-Hover R5X. I went to the LX, and I noticed immediately when I would corner, it felt like it was accelerating faster out of the corners. I didn't seem to feel any reduction in performance as far as on the roll axis, which you would maybe think there would be. Pitch definitely felt really good.
One difference there maybe it occurs to me, your quads are so light that you have so much authority on all your axes. Maybe you're not going to feel that difference as much.
I don't think so. And also, at this point in time, the progress as far as like the firmwares and everything, the flight controllers, I mean, I don't know how much I could tell a difference, to be honest, between a stretch deck. I mean, I don't know. I feel like the stretch decks, in my opinion, seems to be the pick. It accelerates really fast in the corners. It has a good top speed to it. Whether it's faster or not than a True-X or a Squish X, I don't know. BMS Thomas runs a Squish X for racing, and he has no problems with speed, no problems with cornering. I think maybe it's just
I actually have
different.
a note to it. I have a note to why people like the Stretch X, and it's not what people thought it was. The reason people are liking Stretch X is they're actually increasing their footprint, and this is something I've tested. So if you look right here at this quad, this is right now a 7-inch quad running 5-inch props. That's sort of silly. It's silly.
What? That's crazy talk.
That is not my normal platform, but this is sort of an experimental point. And that being said, if we look at another quad over here, this is my race quad that we're currently selling, and this is essentially a True-X that can fit 6-inch props, and this is what we race it with right now. So what I like to show with people, so he has a very small quad, but his stretch is almost as long as my stretch, but I also have the width. So what we're talking about here...
What is the effect of the larger footprint?
So what we've been noticing over time, so I started with flying 185s on 5-inch. These are tiny quads, nearly the smallest you can fit a 5-inch prop in. And we notice they start getting squirrely. Like they're very high powered,
nimble.
very small, so your leverage is very insane on every rotational axis. And when you start increasing it, it actually dumbs down and it softens up and it feels much more
stable.
planted.
Okay.
So I
Stingy,
think
you're dying.
I'm dying to jump in on this one.
so all I'm saying is I've noticed, I think what's happening is when you go stretch, you do increase that area and it gets a bit more stable, but I think a bigger X is even more stable to that.
So we're going to take this back to physics, and we're talking arm length, and I'm not talking about an arm on a quad. When you have a fulcrum, we've got a pivot point, and then the distance that you're from that pivot point that you are applying the force. If you try to say this thing, my hand weighed 100 pounds, for instance, it would be way harder to lift it here than it would if you are out here because physics. I don't want to get too deep into this discussion.
We'll talk about
I want to talk about my evolution in the hobby. So when I first got into the hobby, I was flying a QAV 250. It was 250 millimeters motor to motor, and we kept shrinking things because we got smaller and smaller electronics, more and more things on the same PCB, and I went to the H frames, and then I got on the X frames, and I loved how a symmetric X flew. But when I went to an X, we shrunk them down. We got them down to 180 millimeters for a 5-inch quad, and I loved the behavior, but it was so twitchy because there wasn't that stable platform. When you have that longer arm, you get a much more effective force on all of these axes, and because it's so big and spread out,
I know what you're saying, and I know how to explain it. So
the issue I think is the more centralized you're talking about the torque, which is the longer the lever arm, the more force you get for the same force applied at the end of the lever arm. But also there's the issue of the more spread out the mass is, the harder it is to get it moving. More centralized mass is easier to get moving. So you have less torque on the lever arm, but also it takes less work to get it. And I think the mass centralization dominates over the loss of torque from.
I would agree. That's why when we were working on the Stingy, I was like, I want it big. And there were not many people making big. Right. Everybody was still trying to get it smaller. I was like, no, go the other way.
There's one more point to it is, as you get bigger, because when you pivot, you actually have to travel further distance, so you have to run a higher velocity. So essentially what happens is the smaller and smaller you get, the movements in the prop have to be smaller and smaller. Your RPM changes are smaller and smaller, which means your window for tuning gets tighter and tighter and tighter. And as you get a little bit bigger, you actually have to accelerate the props and give the motors a little bit more time. So you get this mechanical lag in the system, which isn't something that you're going to notice as an input lag or anything other than the system itself gains more time to respond. Therefore, overall, it can fly a little bit more stable with a little bit wider range of PIDs.
We're talking about how the stretching the quad out on a given axis kind of makes it more stable and less responsive, but maybe a little easier to fly. I wonder if you think there's any truth to the suggestion that might be why racers like stretch decks, because they have so much up tilt that the pitch axis becomes really sensitive, and they want that more stability. Alex, no?
I don't know. I think we've been talking a lot about the physics and everything behind this. For me, I don't know as much about the physics and everything behind this. I just know that when I take the same exact setup on a quad, do a squish X, true X, and a stretch X, at the end of the day, it's two important things for me as a racer. Maybe it's different for freestyle guys, but for me in a racer, how fast can I get lap times, and then efficiency. Efficiency didn't really change.
How long can you fly?
Flight times are about the same for everything. So for me, it was how fast is it around the track. I've literally taken quads and built the exact same motor setups and just changed the geometry of the frame. And personal preference is the lap times are the fastest on the stretch decks, and it was the most enjoyable to fly because it just flew the best. So I don't know. I don't know as much about the physics behind it. I just know that the stretch decks quad felt the best in the hands. And I think from a racing standpoint, that's where people are going to decide is just personal preference. I don't think the physics necessarily matters as much. Maybe one day if we really go next level with this drone racing, it will, but I don't know.
I want to ask a question though. From your testing, whereas your X configuration, your stretch, and your wide X, did they all have the same footprint area? Because that's what I'm getting at here is by increasing one axis here, you're gaining that surface area, that footprint overall. Whereas if you took it and you made this a true X, you're actually going back to the small size. So I'm saying, did you make a true X that was the same width that this is currently?
I had it was like, was it R5X So I don't really know. Truthfully, I just know that like the arms, like the center of everything was the same. The arms were just different geometry.
You got a wider platform overall.
You had a wider platform overall with the...
Which is what Zach is saying.
Well, that's what I was asking.
Yeah.
Yeah, you would. I see what you're saying, and that would be an interesting experiment.
Because if you
to
just
have-
took this and shrank it, then where you're talking about it gets unstable. But if you took this and made it wider, then it should be more stable overall.
One point that I think I'm hearing everybody touch on is that, and I wonder if you'd agree or disagree, that the geometry matters a lot less than it used to because the flight controllers are so good and the power systems are so responsive. Do you think that's less of a difference now than it used to? I remember the first time I flew a True X,
totally agree.
it was just like, what is this thing doing?
Yeah.
And now I fly a bunch of different frames and I'm kind of like,
They almost
they
all
all
feel
kind of
the
feel the same. But I'm not putting in lap times looking for tenths of a
That's
second.
the thing is like I'm putting in lap times in like, to be truthful, it's been like 6 months since I've done this testing. But whenever I used to do this, I mean, I could see differences. I wasn't seeing like 5-second differences, but I was seeing 1 second differences between the same exact setup. I would literally unscrew the motors, replace the arms, and put the motors back on. Same tune, everything. Maybe I needed to change the tune. I don't know. And it was just the True X, in my opinion, was slower. I don't know. That's just my testing.
Here's the last topic we're going to touch on. It's the big one, and that is durability. And this goes back to what we started with in some ways, which is weight. Freestylers or racers care more about durability, and how do we think about durability differently as a freestyler versus a racer? Let me throw it to Stingy.
Ooh, I don't know. Okay, my experience with racing was very limited. So I don't want to be the guy that
think about
compares
durability
the two.
as a freestyler?
As a
What are your
freestyle-
priorities?
The priorities, durability-wise, is that it can take crashes on concrete in particular and not break carbon fiber most of the time. You'll never get it to where it never breaks anything. But what I want is I don't want major weak points where I'm like breaking top plates all the time or breaking arms all the time.
What are you willing to give up to get durability?
A little bit of weight, but like we were saying earlier, like, so for instance, the Stingy frame, I could shave quite a bit of weight off of it and give up durability. But I don't want to do that because I like the extra weight. And with the extra carbon fiber in places, I get more durability.
Now, Alex, what happens when you break a quad at a race? If it breaks in the middle of a race, what do you do?
I grab another quad. No, I'm just kidding.
No, you're not kidding. But you're not kidding.
How many
You're
setups
legit.
do you take
How
to a
many
race?
quads do you bring to a race? Don't be embarrassed.
No, there's nothing embarrassing. Like it's a preparation thing. I bring minimum to a big race. I brought 10 quads.
Okay.
So like, and here,
There's a difference. How many do you
I've
bring to a
never
freestyle
had
session?
10 quads.
How many do you bring to a freestyle? How many quads do you have flying right
Okay.
now?
Currently 2, and the most I've ever gotten it up to was 4, and that was for a race. And normally I float between 1 and 3.
Yeah.
Okay, but there's multiple reasons why. Okay, let me address the durability. Let me address the durability of a race frame, then I'll explain why I say bring 10 quads to a race. Okay, when it comes to durability of a race frame, in the past when we went light, like summer of 2017, we were going light, but we weren't like the durability went way down. So like all we were trying to do in that case was make the arms easy to replace, and I hated flying lightweight quads for that reason because if I hit the ground or something, I'd snap an arm. But these days we go to smaller footprints on a lot of stuff, and then by that weight we save, we can put it back into the frame. A perfect example, this frame. This frame's a 20 by 20 stack frame. So we save weight by going smaller in the electronics, going smaller in the center body. That weight we save, we can put elsewhere. So we went to 5mm arms on this. This thing's a tank. I've had this exact same quad prototype since like Sebring of this year, so January, and I have yet to break an arm on this. So it's like in the past, I needed 10 quads for a race. I still take 10 quads, and here's why, because from a racing standpoint, it's all mental. So if I go out there and I start breaking quad after quad after quad, it doesn't matter. Like, I mean, you may not even break the frame. You can break cameras. You can break ESCs, motors. It's a mental thing for me. I need to be able to go out there and not. It's like a simulator. I need to be able to hit reset over and over again.
So
So
you
for
can't
me,
spend all your time repairing your quad.
exactly. So like, I would rather just pick up another quad and then if I have spare time, fix the other ones. And that's how I do well at races. It's just I don't ever worry about not having something to fly. There's always in those 10 quads, at least 5 of those are brand new, and the other 5 are usually like practice quads that I know work. So it's like 5 fresh builds that work, and then after that I have 5 other ones. So it's like 10 brand new quads. I mean, but it's still, you gotta come prepared.
Yeah, for a racer, if you crash out of a race and if you crash and your quad is still flyable and you can get back in the air, potentially you could still finish the race.
Right.
For a freestyler, if you crash, on the one hand, if a freestyler crashes, so you're done flying for the day, no big deal, but it's less at stake. On the other hand, a freestyler may crash somewhere where he can't get his quad back. If he can't get back in the air, he's going to lose the whole quad.
Right.
Whereas a racer, he crashes, he can just walk over and pick it up. So I don't know, there's different priorities there.
So a good point is that race frames, because they're also lighter, there's less inertia in a crash. This is something that I noticed when we made the Shrike forever ago, is I almost never broke it. I actually still have my original prototype that I rebuilt with new electronics. Original prototype. I cut on my own CNC, and the original prototype weighed 230 grams dry. Like, that is a modern day race quad, minus the fact my motors were 2205 Cobras. And comparable power output, it's probably like near half the power output of some of the newer motors. So, yes, lighter weight is much more durable. Now on to
a point.
Eventually
it's so light it becomes fragile. We see a lot of guys trying to beef their quads up. And by adding weight, they actually make it break
also more. A problem, and this was a big problem like all the way back in 2015. You had people building really, really heavy freestyle setups that were all the way up to like 800, 900 grams, and when they'd be like, but it's going to be durable because it's got this thick carbon fiber, and then they'd crash and be like, well, why did that 6 millimeter arm explode? Because you weigh like a kilogram, So Alex is giving me crap saying that the Stingy is really heavy, but honestly, a 600 gram all-up weight freestyle quad these days is still like medium to lightweight freestyle setup. Like Drew, what are you at?
At least 630, maybe 670.
Jeez, oh my god.
You're hurting.
So to that point, that's actually a good point, is one of the main things I did with this current frame when I designed it was, I was like, how do we get sort of the best of both worlds? It's not super light, it's not super heavy, it's somewhere right in the middle. And then I also ran this through programs to do FEA analysis, which is a stress test. So I took all the highlight points out of where the stress on an arm will be in a crash, and then I reduced the number of standoffs from, Stingy, I think you have like 10 standoffs on that frame down to 3.
8.
You have 8?
Yeah.
8. Well, you have your camera ones as well, right?
9.
Okay. So 8, we'll go 8. General freestyle frames run around 8 standoffs. So we went and we took it down to 3 standoffs, and we added a pod to help try to reduce.
The lower deck reduces leverage?
Lower deck to get that weight down, so it's lower leverage. So basically that's what we tried to do here, is I wasn't looking for something that's as light as what Alex wants or as heavy as Kevin wants. And I tried to find what is a middle ground of something that's hard to break, yet still lightweight enough that you can race it. And then on top of it, minimal parts to replace if you do end up breaking it. What's the easiest way to do that? So that's sort of been overall my design philosophy, is keep it simple but keep it durable.
I know we said this was gonna be the last topic. I got one more sort of fun topic to close on.
Okay.
Somebody at Quad Camp this weekend asked me, can you suggest a frame that's good I want to do a little bit of racing and a little bit of freestyle. And I was like, I don't know. Does that even exist? Is there one frame that can do it all?
I think there
Half
are.
decently.
I would say the R5X is a great option for that, honestly, because you can mount a GoPro on it. I had that as my exclusive freestyle setup when I was doing racing, because I didn't want to have it was before the Stingy. I didn't want to have like this setup and that setup. I wanted the same spare parts across the board, so I ran the R5X for both racing and freestyle. And I'm not saying it's the best at either. But
to that point, this is my race frame with a custom 3D print, and it turns into my freestyle frame.
You run the same frame for freestyle and racing.
This is the same frame.
Yeah.
The small difference is my dedicated freestyle rigs, I put in squash arms to help move GoPro out of frame, which is more of a filming decision than it is an actual frame.
I have my point to add. This is my Stingy. I raced at the International Open for like 2 days, like just on and off, against my other racers, and like it's beaten up and whatnot. Like, I don't know, I feel like if I had to recommend a frame, I would probably say just take the GoPro off the Stingy and put a good motor. But here's the thing, like if I was trying to, most people who are trying to find a middle ground want durability. They want to use the same parts, and like
especially beginners care more about durability than performance. They don't want to break stuff.
It's like, well, I think this is like a brick in the air. It actually like has the best of both worlds. I mean, you can race it without a GoPro, it has great durability, and you can freestyle it. But I mean, if I had to go more personal, I'd say this frame right here with the stock standoffs, you can actually, with the stock standoffs and carbon top plate, you can actually put a GoPro mount on.
But no battery up top.
No battery up top, but like it's in my opinion, that would be my option, would be the best of both worlds. But I don't know. It's just, if I was trying to go for the performance, I go with that. If I was trying to go for best overall tank of a quad, I'd just go with this.
All right, guys. Thank you so much for talking about this with me.
We're here today in Houston, Texas, where we just finished hosting a quad camp yesterday. And if you are interested in coming to a quad camp where you can hang out with us, learn about FPV, learn about different setups, actually build a setup, and then go fly it with us, then check out quadcamp.com to see all the upcoming dates.
I'd like to thank all my sponsors who support me with my racing endeavors. Thank Rotor Riot for actually flying me down here to do the quad camp. That was a lot of fun. And honestly, this has just been a great time, guys. I'm really glad to have been coming down here, did the videos, and kind of argue a little bit about the setups that we run. Win 5L, if you want to race what I race, go buy this, and go check out my channel, Captain Vanover.
I'm Joshua Bardwell, and I have a channel where you can learn about all the things you need to get your quadcopter in the air, keep it flying its best, and enjoying the great hobby of FPV. Link in the video description. I couldn't be happier to be doing quad camp and connecting with you guys in the same way I do on my channel in person.
I'm Anu. Check me out on DRL on ESPN. We got awesome racing to show the world. I make the Brap and the Stees. You should check them out on the Rotor Riot store for sale now. And you know what? Quad camp, it's awesome. Rotor Riot, crushing it. Keep it up, guys. Until next time.